Hi, and welcome to this tutorial. This one is about chemical reactions and that they either release or absorb energy. What does that mean? They either let energy out or they need energy. Burning fuel, combining baking soda and vinegar, and decomposing water into hydrogen and oxygen are examples of chemical reactions. Which statement correctly identifies what occurs in all chemical reactions? Matter is either created or destroyed. Well, matter is never created or destroyed, so that's wrong. Energy is either created or destroyed. Energy is not created or destroyed in chemical reactions. Matter is converted into energy. It's never converted into energy. Correct answer is D. Energy is transferred from one form into the other. What happens in all chemical reactions? Energy is transformed from one form to another. Which of the following statements is true about the role of energy in all chemical reactions? All chemical reactions use energy to create matter. They don't create matter. All chemical reactions convert matter into energy. They don't do that. All chemical reactions either release or absorb energy. That sounds pretty good. Let's make sure that. All chemical reactions either create or destroy. Again, key here is destroy. They don't destroy energy, nor do they create. Correct answer is C. All chemical reactions either release or absorb energy. Photosynthesis, baking a cake, cooking an egg, are all examples of chemical reactions. Identify the statement that correctly identifies the role of energy in each of these reactions. Okay, what has to happen to energy for it to occur? So these reactions release energy? Nope. Because when I bake a cake, I need heat, which is energy. And for photosynthesis, I need sun, which means B, these reactions all absorb energy. Photosynthesis, baking a cake, and an egg. All are reactions that absorb energy. Which of the following is necessary for all chemical reactions to occur? Well, there has to be enough energy to make the reaction occur. Otherwise, it's not going to happen, guys. There has to be enough energy for the reaction to occur. The burning of gasoline and cellular respiration are both chemical reactions that A, destroy matter. Well, we don't destroy matter. We don't create energy, but we do when these occur, and this is why some people get confused, they release thermal energy. Basically, they're changing matter from one form to the other. Chemical energy is being converted into thermal energy, heat energy. A student chemistry team put iron powder, carbon, and salt water in a sealed plastic bag with a thermometer. They recorded their initial observations of the substances in the bag, and 10 minutes later they recorded their observations. Their data below shows some of their initial and final observations. Identify the statement below that provides evidence of the role of energy transfer in the reaction. Okay, does the color changing? Nope. Bag filled with air? Nope. Mass should stay the same because that's the law of conservation of mass. But the one that correctly determines that there was an energy transfer is temperature. Temperature is your key indicator of any temperature. So the rise of temperature is our evidence of a role of energy transfer. Photosynthesis, baking a cake, are all examples of chemical reactions. Identify this statement that correctly identifies the role of energy in each of those reactions. Okay, remember we said that these all require heat. Okay? These reactions are exothermic or release heat. Well, that is the correct definition for exothermic. That's not what these are because remember, they require heat. They're going to take it in. These reactions are exothermic or absorb heat. That is an incorrect definition. C, these reactions are endothermic or release heat. That's an incorrect definition. These reactions are endothermic and absorb heat. What do? These reactions require heat, and an endothermic reaction, heat in, absorbs heat. When glucose reacts with oxygen in our body cells, energy is released. This energy is used to move our bodies, heat our bodies, and perform all other body functions. Our body's ability to use glucose in this way means that glucose is stored energy. That's what it is. Glucose must contain energy in order for us to be able to use it. Okay, there you go. Glucose has to have energy for our body to be able to use it to move, heat up, and do all those other bodily functions. Flashlight bodies can be used for a limited amount of time due to which of the following? Well, all the available mass and chemicals have been used up. Guys, what did I say? Mass is not used, right? It changes form, so that can't be right. All the available potential energy has converted to mass. Chemical energy has been converted into mass. Well, we can't convert energy to mass. All the available potential chemical energy has been converted into forms of kinetic energy. That could be true, right? Because we're converting energy from one form to the other, and that's true. All of the available electrical energy in the batteries has been converted into heat. Well, not all the available electrical energy in the batteries is converted to heat. Some is converted to other things. So the correct answer is C. Why are batteries used for a limited amount of time? Because all the available potential chemical energy has been converted into forms of kinetic energy. The burning of gasoline is an example of chemical reaction in which chemical energy stored in the bonds between molecules of gasoline is converted into other forms of energy during the burning process. Identify the true statement about the role of energy in the burning of gasoline. Well, gasoline starts as a chemical energy. Apologize. And then as it goes through the process, what's our final thing? We have thermal, because our car engine gets hot. And is thermal energy released or is it absorbed? You got to make that differentiation. So chemical energy is converted into thermal energy, which is released. That makes sense because the car gets hot. So we're going to kind of put an arrow there and we're going to come back and double check. Chemical energy is converted into thermal energy, which is absorbed. That's not true because our car engine doesn't get colder unless there's something really wrong with it. C, thermal energy. No, gasoline starts out as chemical energy. So C and D are both wrong because they're starting with the wrong step. So I hope this short tutorial helps you understand that chemical reactions either release or absorb energy. There you go, guys. We don't destroy it. We don't create it. We release it or absorb it. Have a good one.